If we start with the ellipse x squared over a squared plus y squared over b squared equals 1, sketch the standard rectangle that we've seen several times, and we want to express the equation of an ellipse with the same values of a and b, that is, the same dimensions. This dimension from here to here, a being called the semi-major axis, b being called the semi-minor axis. The whole axis from here to here corresponding to a long diameter, say, is the major axis, and this, the shortest possible diameter, is the minor axis. If we want to express the equation of an ellipse centered at x naught, y naught, okay, that's supposed to be an arrow down there to the point. It's kind of blurred, kind of written blurry, not just blurred. Center of the ellipse is x naught, y naught. We come out distance a here and up distance b here. Then what are the points going to be? Well, we're going to have x equals x naught plus a here. Coordinates of this point would be x naught plus a, y naught, since the y coordinate along this line is always y naught. And this point would be x naught minus a, y naught. If we come up from x naught, y naught up b units, we end up at y naught plus b or y naught minus b. And the coordinates, of course, would be x naught, y naught plus b, x naught, y naught minus b. What's the equation of this ellipse? Well, this ellipse is identical to the original ellipse, but it's translated x naught units in the x direction and y naught units in the y direction. We accomplish those translations by replacing x by x minus x naught and y by y minus y naught, so that the equation x squared over a squared plus y squared over b squared equals 1 becomes x minus x naught squared over a squared plus y minus y naught squared over b squared equals 1. Then we see, for example, that if x equals x naught, x minus x naught squared is, of course, 0. And we have y minus y naught squared over b squared equals 1, so that y minus y naught squared equals b squared. Y minus y naught is plus or minus b, so y is y naught plus or minus b. Consistent with the picture that we've just drawn. And this tends to at least validate, to an extent, the procedure that we've just used. Similarly, if we want to translate a hyperbola so that its center lies at x naught, y naught, here's x naught, y naught, we do the usual construction, a units this way, b units here, symmetric, a rectangle symmetric about the central point. Draw the diagonals. These diagonals are going to be the asymptotes. If we have a hyperbola with the y squared over b squared term positive and the x squared over a squared term negative, then when we translate it, we end up with this hyperbola and the red hyperbola, this equation and the red hyperbola. If the x term is positive and the y term is negative, we end up with the blue hyperbola. And these points will be the same as the points that we labeled for the ellipse, the 4 vertices of the 2 different hyperbolas.